All right. So we're looking at our day 1 notes. Right now we are not playing with calculators. You don't even need them right now. You can use them on the homework, but you don't need them right now. Okay? So make sure you are looking at day 1. There's 2 of them. Day 1. Okay? So these are some real world examples of scientific notation. The world's population, huge number. Distance from Earth to Sun, huge number. The number of cells in your body, I don't even know how to say this huge number. The mass of a particle of dust, tiny, tiny, tiny number. Okay? So these are real world examples where you see scientific notation. All right. So it's super easy. You're going to start with having a base of 10, okay? So the 10 is the base. And what's that little 5? What word do we use for that number up there? Yeah. Which, day 1 or day 2? Okay. I think Jules put them up there. So it's the exponent. Make sure you're doing the day 1. There are 2 of them, okay? So the exponent is this little bitty guy. This is what expanded form is. It's this big, long number. We may not have gotten enough. Okay, just so y'all know, I gave this to y'all yesterday. Did every single person lose it from yesterday? Make sure you're grabbing one that says day 1. You should have one that says day 1 and day 2.
Oh my God. Thank God she gave me the whole stack.
Oh, she gave you a bunch? Okay.
She said she made extras.
Okay. All right, so day 1. Here's this big, long number, and we're going to work on putting it in scientific notation, okay? So if you look at this first column, these are all in scientific notation. What do they have in common? There's a couple of things.
They all are times 10.
Okay, so they're all times 10. They're all multiplying. What else do they all have in common?
They all have an exponent.
They all have an exponent. The other thing you may not notice, it's the one that's a little bit weird. Does anybody notice anything about the beginning numbers?
It's irrational.
Okay.
It needs to be rounded.
Okay, so we have some decimals, we have some whole numbers.
There's
But
like a negative at the bottom.
so what you need to know is you can only have one number in front of the decimal. So that's why on the video he was talking about it has to be a number between 1 and 9. That means there's only one number in front of the decimal. Okay? And it cannot be 0 because here it says it has to be between 1 and 9. So you can't have 2 digits and you can't have 0. So if you look at the second one, 3, where is the decimal on 3? It doesn't have one. So if it's out of sight, the decimal's on the right. So this is really 3.0, okay? You don't have to put that there, but I'm drawing it there so you understand. Oh yeah, it really does have one number before the decimal, okay? One number before, one before, one before, one before. Sometimes they have 3 after, none after, 1 after, 2 after. It doesn't matter, but they can only have one before, okay? If you look over here at the ones that are not scientific notation, what's wrong with the first one?
There's 2.
It has 2 numbers in front of the decimal. What's wrong with the second one? It's addition. What's wrong with the third?
It's 2. There's 2.
There's 2 numbers in front of the decimal. What's wrong with the last one? There's a 0 in front of the decimal. You can't have a 0. It has to be a 1 or 9. Okay? So in order for it to be scientific notation, it can't have 2 numbers. It definitely can't be adding. And it has to have at least one number. It can't be a 0. It's got to be between 1 and 9. So that's how you know if you're doing it correctly. Okay? Now to actually solve it, it's super easy. Okay? So we know our first digit has to be between 1 and 9. And then we have an exponent. It's always times 10, and we have an exponent. And our exponent tells us the number of times we hop or jump and I'll tell you what that looks like in a minute. Just for now, write it. It tells us the number of times we jump, which we move our decimal, okay? So if it's positive, we're going to the right. If it's negative, we're going to the left, okay? Positive to the right, just like a number line, if you think about a number line, okay? Positive goes to the right, negative goes to the left. All right, so the first one. They gave it to me in scientific notation, and I need to do it in standard notation. So what you want to do, I have old eyes. Maybe you can see these little numbers good. I always rewrite it. Okay? Now, put your finger or your pencil on the decimal. The 6 tells me I'm going which direction? Why am I going to the right? Because it's positive, yeah. The 6 tells me I'm making 6 jumps. So literally you're just going 1, 2, 3, 4, 5, 6. So now my decimal is right here. What do you think I should fill in with? Zeros. 1, 2, 3, 4. So it doesn't mean there's 6 zeros. It means there's 6 hops. So this number is 5,030,000. And that's literally all we're doing. You're moving your decimal.
He made it sound so much more complicated than it really was.
Yeah, you're moving your decimal, okay? The next one is 4. Ooh, 4 doesn't have a decimal. Out of sight, put it on the right. All right. What does the 3 tell me? To hop 3 times. Which direction? To the right. So 1, 2, 3. So this time, I have how many zeros? 1, 2, 3. So my answer is 4,000. All right. The next one, it's a big, long number. 4 times. Positive 4, so which direction?
Right.
To the right. So I'm going to try to do this. My old eyes just have a hard time. 1, 2, 3, 4. So now where is my decimal? In between what numbers?
5.
In between the 5s. So 1.0395. Oh, sorry, that 1 is not there anymore. That's not a... Miss Davis. It's 10,395.5 times... Oh, not times. Oh, my gosh. Just that. Sorry. My brain. It's 10,395.5. Does that make sense or did I confuse y'all? Okay, sorry. All right, the next one, 8.2. It's a 5. Which direction am I going? Why? Because it's positive. 1, 2, 3, 4, 5. How many zeros? 1, 2, 3, 4. So it's 820,000. Pretty easy, right? Just moving it. Now we want to practice going the other way. Now I have this long expanded form and I want to do it exponential. On the number 2,000, where's my decimal?
Oh wait, no, it's all the way after the 0.
It's at the 0. Okay, where do I want it to go? I want it to be right here so that I have one number. Okay, how many hops is that? 1, 2, 3. So it's 2 times 10 to the 3rd. So it's always times 10. And then again, I'm getting the exponent from the number of hops that I made.
Making a little more sense.
Yeah, that's not bad. All right, 91,700,000. Right now the decimal is at the end. Where do I want it to be? After the 9, because I only want one number before. All right. 1, 2, 3, 4, 5, 6, 7. Did y'all get 7? 9.17 times 10 to the 7. For some reason, these 2 questions printed on the back. So if you'll just write them, because then when we glue on it, otherwise it won't be there. All right, 17,000. Is there a decimal?
All the way at the right.
All the way on the right. Where do I want it to be?
In between 1 and 7. Yeah.
1 and 7. How many hops?
4.
So what do I write?
1.7 10 to the 4th power.
Good. All right, and the last one, 6, comma, 531, comma, 270, comma, 000.
6 billion. 5 million. 27,000.
Where's the decimal?
The end.
The end, where do I want it?
In between 6 and 5.
Between the 6 and 5.
Yeah.
6.53127 times 10 to the 9th power. So you have to write all those numbers, but then when it starts getting zeros, you stop. Okay? Everybody feel okay with that?
Yeah.
All right. So now let's look at day 2. Day 2 is the exact same thing, but it is negatives. The exact same thing, it's just negatives.
There's always except or but.
But it's not hard. But I said but again. All right, here we go. So again, scientific notation. This is going to tell you the number of hops or jumps and which direction. This first number still has to be between 1 and 9. Okay, so it can't be 0. Can't be anything bigger than 9.
Can I close the door?
Yes.
Oh, my leg's sick for sure.
All right. So this time, what do we have in front of our exponent?
Negative.
A negative. Oh yeah, I forgot to tell you that I got a ghetto doorstop there.
I didn't crack this. That's actually a good idea.
If anyone is listening to this video, please buy me a doorstop. All right. So when it has a negative exponent,
Isn't this a good one?
yeah, it doesn't work. There's too much space between my door and the floor. I don't know why.
What about the 3D one?
Okay. So when it's negative, you're not multiplying big numbers, you're multiplying fractions, which is why it's a small decimal, okay? So you do it the exact same way, you're just going the opposite direction, okay? So this is scientific notation because it has one number in front of the decimal. It has a times 10. We want to write it in standard, okay? So 8.9, I have a decimal. What does the 4 tell me?
That it's
4 spaces. What does the negative sign tell me?
to the left.
To the left. So now I'm going to go to the left. 1, 2, 3, 4. 1, 2, 3. So it is 0.00089. Now on multiple choice test, you're going to see a 0 in front of it. That's fine. It doesn't. I mean, you don't really have to have it, but you might see it on multiple choice test. Yes.
Are we allowed to use notes on the test?
Not on tests. On quizzes and on homeworks. All right, the next one, 4.41. Right now, the decimal is between the 4s. Which direction am I going?
To the left.
How do you know? It's negative. 2 to the left. 1, 2. How many zeros? 1. So it's 0.0441. All right, the next one, 1.326. How many spaces? Which direction?
To the left.
To the left. So 1, 2, 3, 4, 5. Fill in with zeros. 1, 2, 3, 4. 1, 2, 3, 4. 1, 3, 2, 6. Okay. Notice when I'm looking at the standard form, it's a long number, but it's tiny, 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 tiny. It's not even a cent. Not even like anything that we know. It's tiny, tiny, tiny. All right, so now let's figure out how to take your tiny, tiny, tiny numbers to go to standard notation. Okay? Right now, where is the decimal? It's at the beginning here. Where do I want it to be?
Five.
Right after the 5. So how many hops will that take? 1, 2, 3. So it's 5, bless you, times, bless you, 10 to the what? Negative third. And how do I know it's negative?
Because you take from the left.
And it's a tiny, 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 tiny number. If it's a tiny, tiny, tiny number, it's negative. Okay? And also, you can look at the way that you moved. All right, the next one. Where do I want the decimal to be?
Past the 7.
Right past the 7. And remember, that's because I only want one number before the decimal. Okay? Oh, how many hops? 1, 2, 3, 4. So it's 7.83.
Times 10 to the negative. Your hair is in the camera.
Sorry. Times all my gray hair.
No, it's just like part of your like. It's like the top of your head. Yeah.
That's gray. 10 to the what?
The negative fourth power.
Negative fourth power.
No, but it's just like your little baby hairs. You can just see them.
All right. Last one. Where should the decimal go?
After the 8. After the 8.
After the 8, between the 8 and the 9. All right. So I know it's going to be 8.9 times 10. We want to count. 1, 2, 3. What'd y'all get?
8.9 to the negative 6th power.
Negative 6. And why is it negative?
Because you had, it's a tiny number.
Tiny number. Good. All right. Everybody okay? Are you thinking, is this super easy?
It's alright.
Okay. If you're confused, ask. We're going to do these last 3. So we're looking at some biological structures. A lymphocyte has a diameter of 0.0009 meters. Okay? First of all, what the heck is the diameter?
It's not small, it's like a
It's like a
millimeter.
circle around a circle.
It's
halfway.
I thought it was like
We talked about this last year. I know you learned it because I taught you last year. Diameter is all the way across a
and then
circle.
radius is like half,
Yeah.
and then the
So
circumference is the whole thing.
Okay. So all the way across is this little bitty number. Do you think these these lymphocytes are huge or tiny?
Tiny.
Like if you look at the tip of your pen or pencil, like it's way smaller than that. Okay? These are lymphocytes. I want to know what that is in scientific notation. Where do I want the decimal to go?
Past the 9.
Past the 9. All right, so count.
1, 2, 3, 4, 5, 6.
How do I write this?
9 times 10
times 10
to negative 6th power. Yeah, Carson.
All right. So again, we want it to be a whole number in front. It's got to be between 1 and 9. Let's do the bottom one because we're doing that same direction. Okay? Where do I want the decimal to go? Between the 7 and 8. Do your little hops, jumps. How many was it?
5.
What kind?
Negative 6.
Negative 5. Yeah, 7.8 times 10 to the negative 5th power. Okay? All right, last one. Now we're going the opposite direction. Okay, 9.5. The negative 8 tells me what?
To the left.
And how many?
8 times.
8 times. 1, 2, 3, 4, 5, 6, 7, 8. All right. Fill in with all those zeros. How many zeros did you put?
7.
7. 7. So if I asked you to compare them, do you think it's easier to compare when you can see which one has more numbers, or is it easier to compare when you're looking at the scientific notation? Okay, if you're looking at scientific notation, you have to look at the exponent. Okay? To me, it's easier to write this out, but we're going to do a couple of those on tomorrow's assignment and next week. Okay? Everybody? Yeah.
Is this homework?
Yes. Okay, everybody feel okay with scientific notation?
Yes.
All right. Fold it up. I will come around with the glue. These are page 5 and page 6. Obviously, day 1 is 5. Day 6 is 2. Day 2 is 6. And you have 15 minutes, and we caught up, and you still have lots. Y'all missed out on the quizzes on You missed out on the quiz on Brain Pop, but would you rather do that or would you rather have time to start your homework?
Time to
Oh,
wonder.
okay, that's what I figured.